The weight in kilograms and age in years of a person is expressed by the equation y equals 2x, where y is in kilograms and x is in years. Draw the age weight graph from the values of the following table. You don't have to make a table from the equation y equals 2x, but this is one is even easier because they gave you the table. So here x are the years. When the person was 5 years, his weight was 10 kilograms. When he was 10 years, his weight was 20 kilograms, and so on. Even I can get this trend from the equation y equals 2x. It means whatever was the age of the person, the weight was double to that value. For example, when his age was 5 years, his weight was 10 kilograms. When his age was 10 years, his weight was 20 kilograms, and so on, because y equals 2 times of x. Now it's time to draw the graph. So here I have a sample of a grid or graph paper. So I assign like x axis, horizontal axis is the x axis, and vertical is y axis. And now I have to choose the value. So I just take one unit, one box equals 1 unit horizontally. So x values, I assign the values. So 5 years, 10 years, 15, 15, and then 20, 25, and 30. So this is how we make the horizontal scale, and then in the same way I will make vertical scale, because I have only positive values, so I don't have to worry about the other side of the axis where I will usually display negative values. So now here I will only write positive values. So for the vertical, the first line is at 10 kilograms, and we also need to mention the unit so that we won't forget. And the unit for x-axis is years. So here are the years, and for y-axis it's kilogram. Now I can finish my y-axis. So the next should be 20, 30, 40, 50, and 60 kilograms. So this is how we set up the graph. Now we can locate the ordered pairs on this graph. We have set up the scale, units, everything is fine. So let's start locating the ordered pairs given in the table. So for the x is equal to 5, it means then when the age of the person is 5 years, his weight was 10 kilograms. So I will go along the x-axis, stop at 5, and then I will go up and I will stop where y is 10, and here I will locate the point. Similarly, when age is 10 years, I will go along the x-axis 10, and then the next value of the y is 20. I will go up, stop in front of 20. Here is that point. For 15, it's 30. For 20, it's 40. For 25, it's 50. And 30, it's 60. This is how we locate the ordered pairs given in the table. The next is to join these points through a straight line. So I will start from first point. You can place a ruler and then join these points. So this is the age weight graph. But merely drawing the graph is not enough. You should be able to understand what is it showing and to conclude or get some necessary information out of it. For example, it's easy. I can see that when age of the person is increasing, I can see along the x-axis age is increasing, is 30, then it will be 35, and then 40, 45, 50. His weight is also increasing. That is what this line is showing, because this line is going up and up. So it is showing that along the x-axis, when the age is increasing in years, his weight is increasing. One more important thing, that this relationship is linear. It means the graph of this equation is a straight line. So when you have a graph of this equation as a straight line, you can actually extend it to any level you want. Just keep it in such a way that all the points should be on this line. And now I have extended it to this scale, to the end of the scale. So what does it mean? Let me tell you that it means something, because you can use it to predict the consequences. For example, I want you that what is the a what for example, you have this data, right? When his age was 5 to 30 years, you have his corresponding weights in kilograms. So my question is that when his age is 40 years, what do you think his weight would be at that time? So now it's easy. Just go along the x-axis and you can extend this graph, right? Because one box equals 5 years, right? Because the difference between the one line and the other line is 5 years. So I can extend it to 35 and then 40. I can even go up to 45 and 50 years. According to this scale, I can predict his weights up to 50 years. And of course, it's easy to extend the scale. So my question was that if his age is 40 years, so I will go along the x-axis because these are his ages. I will go at 40 and then I will go up, 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 and I will just stop at the line, wherever it is. And here I will make a point, and that point should be on this straight line. That is very important. And now when his age is 40, I will go up, and now I can predict what is this value. So I can extend this graph as well. So my step along the y-axis are in 10 units. So here it is 70, and then 80, and then 90 kilograms. So I predict that when his age is 40 years, his weight will be 80 kilograms. So you see, we can use the graphs to predict the outcome of the future. You see, for example, here, according to the scale, that when his age is 40 years, his weight will be, the straight line should be 80 kilograms. So we use graphs to predict sometimes, because we know the trend of the data we already have and we can predict it. But always remember, when you are predicting something, that don't forget the ground realities, because this is a straight line and technically I can extend this line to the other way, right? As long as this line is passing through those points here. So mathematically it is correct, because if the graph of a straight of an equation is a straight line, you can extend it both ways, and it's all right, because that relationship will still hold. But now here is the problem, because if you forget the ground realities, you may predict wrong results. And here I tell you how. For example, now according to this graph, and if I follow the mathematical way, I have to say that the x-axis here, the graph is -5, and then here is -10 years. Here it should be -15, -20, and -25, right? This is how we make the axis. On the right, we usually display positive values, and then on the left, we display negative values. So what if I am here, and what does this point tells me? Because this straight line predicts everything. the graph of the equation. So I say, okay, you have extended the line on the other way, so just pick any point on the line, and what does it say? It tells me that if you go up, this point tells me that at the age of -20, this is how the graph should look like. That at the age of -20, his weight will be, now here I can also display the values for it, right? This is -10, -20, here it is -30, here it should be -40. So I can predict that at the age of -20 years, his age will be -40 kilograms. And if you predict a result like that, the people will laugh at you because this is nonsensical. What are you saying? That when his age is -20, his weight will be -40 kilograms. So whenever you want to use the graph and you want to predict or you want to understand the graph, what does it show? Or you want to get the information out of that, always be careful and don't forget the ground realities, that this graph is not mere mathematical points like we have been doing before in the lecture. Now here you have to see that what does it show. It is showing age in years, and we don't have any negative ages like -10 years or -20 years. And this is just nonsensical. Similarly, when we measure the weights, it's like 5 kilograms, 10 kilograms, 20, 80 is always positive number, right? It's nonsensical to say like the weight of a person is -40. So never do that. And although mathematically it is all right, you have an equation of a linear relationship and you can extend it in both ways. There is nothing wrong mathematically, but there is something wrong with the ground reality. So always display it like this. Forget about the negative sides, both for the weights and for the ages. And this is the graph, and you can predict some values, and it shows a relationship that when age of the person is increasing, he is gaining more and more weight. And once again, although this is all right, and you can extend it this way as well. So if you go along this axis, don't say like it will go on it will go on like this. For example, when the age is increasing, so now I can predict that when his age is 50, his weight will be almost 100 kilograms, right? This is the graph is showing that at the age of 50, his weight will be 100 kilograms. So don't take it very lightly that this relationship holds for some region, but when you cross the limits, always be very careful that whether it makes sense if you want to predict something, because at the age of 50, so if you keep going like that, it will predict like at the age of 60, its weight will be 120 kilograms, and at the age of 100, according to this relationship, because whatever is the value of the age, the weight is usually double in kilograms. So at the age of 100, I can predict that his weight will be 200 kilograms, but it's just nonsensical. So always be careful that whenever you have a graph, try to understand the values. That this is why we show the units, so that you can predict that this relationship holds between some range. For example, when a person is developing, he is 5 years, 10 years, 20 years, his weight of course increases linearly. But after crossing in an age, for example, 30 or 35, the growth of the person stops and it increases very slowly. So this relationship may not hold very well. And another thing, that this relationship is general, it's not a specific, it's not true to every person you find. So it may not be true for anything, it's just a general relationship which tells us that when age increases, weight increases, and there are some boundaries to that.